Okay, this is a very short video. I will explain the three problems I gave in the last video because a number of you have got really confused about them. Rather than correct them individually, they are not going to be graded in any case. I will solve them here for you and provide some explanations at the same time. This is going to be a fairly short video, at least I expect it to be. So the first problem was 1 kg of dried figs cost rupees 1200. How much does 150 grams of figs cost? Now this is a simple règle de trois. 1 kg you get 12, you have to pay 1200 rupees. So 0.15 kgs, which is what 150 grams is, you have to pay 1200 into 0.15 is equal to 180 rupees. Remember, the rupees is important, otherwise it is wrong. Okay, now we go to the second problem. The second problem was, let me cover up what's not required. If 8 metro tickets cost rupees 280, how much do 5 tickets cost? And total ticket cost and number of tickets are proportional. So if you buy double the number of tickets, you pay double the number of price, double the amount in rupees. So here I said swa te se is equal to total cost of tickets and te number of tickets. Just to avoid having to write this 3 words each time. Okay, so what is the first thing we do is we calculate the cost of one ticket. So 8 tickets cost 280 rupees. One ticket costs 280 divided by 8. Each ticket costs rupees 35. Now 280 divided by 8 gives 35. Now this bit I'm not explaining, you of course know it. Now we know that this is a linear function because they are proportional. These two quantities are proportional. Total ticket cost and number of tickets are proportional. So this relationship between these two quantities can be expressed through a linear function. What does a linear function look like? It looks like f de x est égal à ax. So in this case, this is our a. If we write this as a linear function, it looks like that. TC est égal à 35 fois nt. Now this is very simple, it's very intuitive. Total cost is equal to number of tickets into 35 rupees because each ticket is 35 rupees. So this is a linear function which represents this proportionality. Okay, so if two quantities are proportional, they can be written, their relationship can be written as a linear function, which is what we have done here. This is the answer you had to give. But I asked you to give two linear functions. So how do you get two linear functions for this relationship? So there's a very fundamental aspect of this is that okay, we'll come to that. So if we write, I'll explain that just now. Write this as another linear function. And we write this as this. We put nt on the left and tc on the right, and we just do a little bit of algebra and we get this as the other linear function. So this linear function expresses the relationship between these two quantities that are proportional. This linear function expresses the relationship between these two quantities that are proportional. So both of these linear functions are expressing the relationship that exists between these two quantities, total ticket cost and number of tickets. Now why is this? This is because of this very fundamental rule. If A is proportional to B, then B is proportional to A. So if A doubles, then B doubles. But also if B doubles, then A also doubles. If A becomes 1/3, B will become 1/3. When B becomes half, A will also become half. So these numbers are linked, these quantities are linked. A and B are linked in a certain proportionality, in a certain ratio, which is our A here. So, and B is proportional to A. So, both of these, each one of these half statements, A is proportional to B is proportional to A, leads to each to a separate linear function. Okay. Now, let's come to the last problem. Number of you forgot to watch the video till the very end when I asked you to draw a graph. So some of you haven't drawn a graph, and some of you have drawn graphs which are truly amazing. I'm almost tempted to share them with the rest of the class. You'll see once I solve this problem, you will know who, at least the one who's done the funny graph will know who it is. Okay. If T and S are proportional, fill in the table. So I'd given this table with question marks to represent what to fill in. T and S are two quantities that are proportional. Now if two quantities are proportional, we have seen if one is 0, the other is 0. So these two values in red I can write immediately. Because if T is 0, S is 0. If S is 0, T is 0. This is a fundamental property of any proportionality. See, if you go back to our tickets here, if the number of tickets you wanted to buy were 0, then the total cost would be 0. If the total amount of money you spent for the tickets was 0, then the number of tickets you would get for that amount spent would be 0. So this is very easy to fill in. Now, so how do we solve this problem? We can say if T and S are proportional, then S is equal to A into T. This is a standard format of a linear function. Okay. From the table we know that when S is equal to 8, T is equal to 5. This was the first value given in the table. So we can write 8 when S is equal to 8, T is equal to 5. We can write S is equal to A into 5. From this equation we can just replace two values of S and T, that is one value each that we know. So we get 8 is equal to A into 5. This we can use to, from this we get A is equal to 8 over 5, and we can find our 8 over 5 is equal to 1.6 virgule 6. I'm using a virgule instead of a decimal point. So the function is S est égal à 1,6 fois t, and this is a linear function which expresses the relationship between S and T, which are proportional, T and S. Okay, now we can fill in the table. So to get from T to S, we just have to multiply by 1.6. So if it is 6 here, we can do 9.6. If it is 9 there, 9 into 1.6 is 14.4. And to go from this to that, we divide by 1.6. So we can get from 10 to 6.25 and from 9 to 5.625. This is the correct answer for filling in the table. These zeros we had already filled in earlier. So from here we have said S is equal to 1.6 into T. We can also write this as T is equal to 1 over 1.6 into S. This is what you're doing. If you're going from here to here, you're going from S to T, you have to multiply by 1 over 1.6, which means you have to actually divide by 1.6. So this is also a linear function. So these two linear functions express the relationship between T and S. And the only way we could calculate this is because one set of values was given to us for both of them. If one of these was also a question mark, then we wouldn't know what is the relationship, because we wouldn't have been able to calculate the A, that is a coefficient. Remember coefficient? This term will now come often, coefficient. Whenever they ask you to calculate coefficient in one of the problems in the book, they will be meaning you have to calculate A. Okay. Then the last part is you have to do the graph. And how do you do the graph? Well, this is a linear function. So the linear function, the graph is very simple. It's a straight line. Remember, a straight line. I'm talking to specifically to one of you. You had a very, very interesting graph. Well, another one also of you had a zigzag sort of graph, but one of you had a really artistic graph. So it's a straight line, a linear function, always a straight line, always passing through the origin. Origin means 0x, 0y. So we need not even have calculated all of these, because to draw a straight line we need to know 2 points on the line, and this is a graph that it will be. On t you take 5 here, from t, on t you take 5, because you know when t is equal to 5, s is equal to 8, and you mark out s as 8, avec antécédent 5, on a l'image 8, you mark that, and you just join it with a straight line. This is the graph. You need not even have calculated this bit or this bit or all these values. You could have drawn this graph given the fact that t and s are proportional, and you could, and that when t is equal to 5, s is equal to 8, you could have drawn this graph. Okay, this is where I end. I'm not going to respond to your comments individually, to your work individually. This is going to be in lieu of that. You can see what you did wrong yourself, or what you did right. Some of you did everything right, some of you did quite a few things wrong in these problems. Okay, I'll stop here, and through WhatsApp I will now give you the problems to do. We'll start on the problems. Okay, let me show them a little to you. The book is right here. So I asked you to do these oral problems on page 98. I assume you have done that. You can read these two problems. They're not really interesting. If you skip them, you don't lose anything. But on this page, which is page 101, they do one problem worked out, exercise résolu, and they do exactly how you're supposed to do. And you know, it seems quite long, but it's very, very simple. You know how to do it. And similarly, they ask you to do 6 more problems number 2 to 7, but see, they're all in orange, so that means they're all worked out. So I would suggest you do 1 or 2 of these on your own. You can choose which ones. Don't submit to me. Check the answer at the back of the book. Okay, and on this page there are some simple problems here. It's called à l'oral. This is page 102. So these problems you're supposed to do orally. These are calcul mental. These you're supposed to do in your head. But I will give you some problems from here and here and here to do. You do them very fast. They're very, very simple. Some of them will take less than 30 seconds to solve. Some of them will, like this one here, you can solve it in less than 3 seconds. So I will give you quite a few problems, because we have got slowed down a little, because you know you had problems understanding what are linear functions, but now that I'm sure you have understood well, we can speed up a little bit. Okay, I'm going to stop here and then upload this video and then give you the problems to do for a graded assignment. Oh, okay, just one more thing I want to add is that in this graph, all these points will be on this line. So if you take 9 here, if you take t is equal to 9 here, you will, if you join it with this straight line, you will get s is equal to 14.4. Similarly, if you take 6 here, if you just go one more square and you go up, it will cross the image will be 9.6, which is 8, 9, it will be about there. So don't think that these points don't make sense. All of these points also lie on this line. I forgot to say that earlier. Okay.